Okay, this is February 16th. Doing some more quant questions. Number properties, percent. Same sort of theme that we had last time. We just went through the rules and regulations and nitty-gritties. And here's the copyright notice again. When we show you problems that we don't source, they are from the free GMAT prep, although actually most of today's are from our materials. So, and don't forget that this is where you find the multiple choice options. Okay, let's do one. Let's do a problem. How about this one? This problem is from our materials. It's not from the free GMAT prep. Give it a shot. It's data sufficiency. Also, just so that you know, we do assume that you are conversant with the format of data sufficiency. Like, in other words, we assume that you understand what the answer choices mean and what the sufficient and not sufficient is all about. And just the basic format of data sufficiency is a thing with which we assume familiarity. So, okay. Anyways, give it a shot. Please indicate your multiple choice answers here and not in the chat. Thank you. Okay, remember what time management is on this exam, what it is and what it isn't. Time management has nothing to do with minutes and seconds and has everything to do with not continuing if you are not making genuine progress. So if you are still actually making positive progress on this problem, feel free to keep working on it. If not, you should pick something. Okay, let's talk about it. All right, I got a bunch of stuff here. And remember what today's topic is, by the way, which is number properties. There's going to be some percents in there and stuff too, but so you should know these have to do with some sort of property type of thing. Also, you should make sure that you get takeaways as far as cues to make you think about certain things when you see certain other things. Like when you see absolute values, what should you think about? Like what property of numbers should that bring to mind? Yeah, it's doing signs, right? Because the absolute value is just a thing that acts differently according to the sign. So this should, like basically when you see this, this is almost like an alert to you to think about signs, is what this is. So positive, negative, 0. Don't forget that 0 is a thing. I mean, that may or may not be significant in any particular problem, but this is basically a broadcast. Hey, you, think about signs. Okay. Also, this kind of stuff, you got to look at the conditions in the problem. I mean, sometimes they're just bookkeeping, and sometimes they're significant. Like when you see these things that are up here, after the word if, what's going on with AB not equal to 0 and A plus B not equal to 0? What are they doing there? Can anybody tell me? Again, this may or may not be significant, depending on the problem. Yeah, this is just making sure that you don't divide by 0. So, like, in other words, these are not conditions that you are actively going to use in the problem, but they just have to make sure that you are using numbers that are actually legitimately defined numbers. So good. Whereas, like, sometimes the stuff after the word if is conditions that you actually have to use to solve the problem. So, but this is what I call bookkeeping. It's just making sure that denominators are not 0. So, smiley face if that makes sense. Like if A plus B were 0, you'd be dividing by 0 here. And if this product just means that neither of them can be 0, because if either one was, then this would be a problem over here. So, okay. Also, remember, this is a yes/no question. We built some machinery for this in other Thursday workshops. But the deal is you need to translate what the word yes actually means in terms of numbers and specifics, and what the word no also means in terms of numbers and specifics. So let's do that. I mean, if the answer to that question is yes, that would just mean the less than sign is actually a less than sign. And if the answer to that question is no, then it's a greater than sign. So let's translate those. Yes to this means that it says what it says. And no would mean the same thing with what sign, where it says less than right now. Like what would go here instead of less than? We would say greater than or equal to. Don't forget equal to. I mean, you can still, that's also a thing that you can use. So, okay. And again, this is a piece of machinery that we've built up in some of our workshops about yes, no questions in particular, but it's always a good idea to set this kind of thing up. Statement 1 in one column, statement 2 in another column, and then if you have to combine them both in a third column. And then what we're doing here is we put check marks in these things if you can make them happen. So what you have now is you have the actual goals of this process in front of your face, as opposed to having to remember what they all are in your head. So check mark if you make something happen. And then remember what this is. If you can make them both happen, then that's what not sufficient is. That's the point of this, is to visualize the yes/no format. So if any column has 2 check marks in it, then that's not sufficient. Okay, give me a smiley face if you see what we're doing with this device. Again, we've had entire workshops on this in the archive. But the reason why a lot of people have difficulty with data sufficiency is because they don't have goals that are actually goals. Like these are not goals. I mean, you can't pick numbers that say yes or numbers that say no. So honestly, when people are still having difficulty with data sufficiency problems, part of it is they don't have goals. Whereas that's what these are. These things are actually specific goals that you can try to make happen. Okay, it's important. Let's do it. What does statement 1 mean? Yeah, if you think about statement 1, you got to think about positive, negative, and 0, but here you don't because they rule out 0. But you want to be thinking about signs already. And then this is not something you can really do algebraically. I mean, nor you just, you can't. In general, when you have absolute value things like this with more than one absolute value, you're not going to really be able to use algebra. I mean, there are some very specific types of things that you can solve algebraically, like if it's just one absolute value is less than or greater than something, then sure. Not something as weird as this. So you just want to think about signs. So here's statement 1. And remember that 0 is off limits because they said so in the conditions of the problem. So we just got to think about positives and think about negatives. And yeah, a couple of you have said it in the chat box. And if you think about when these would be equal, like basically if either of these things, if either A or B were negative, then the absolute value would be positive and it would be bigger. So, I mean, if 0 were allowed, we would also have to think about 0, but it's not because the problem rules that out. So, otherwise that would be a thing. We have to think about it. So, but something to think about 0. And then if either A or B is negative, then the absolute value is less than the original number because it's negative. Or the absolute value is greater. So because it's positive. Smiley face if that makes sense. So what this means, and there's no way to like make up for that. Like if A is negative, then this is less than this. And you can't make this greater than that to make up for it. So this means the only way that you can get them to be equal is if both of them are positive. Two sides can, it is impossible for the right-hand side to be bigger. So the two sides can then be equal only if A and B are both positive. So that's what we know. We know they're both positive. So statement 1 is just a really stupid way of telling us that both of them are positive. You'll see a lot of this in number properties. Like a lot of what we call number properties in these problems is just them telling you things in ways that are very, very indirect. Like in this case, this is a hugely indirect way of just telling you that A and B are positive. Okay. What do we know about these now? And if we have two positive numbers, let's think about 1 over A plus B versus 1 over A plus 1 over B. What do we know about those? What you might have tried to do is make some sort of common denominator or something, but if you do that, you're going to find that you get into some mess of algebra, which is not so great. Although, well, maybe we can try common denominator in a sec. But if you try plugging in numbers, if you don't see a relationship, what you should try doing is you should try plugging in numbers to investigate it. That's the deal. I mean, at the very least, yeah. I mean, you might want to just do the whole thing by testing cases, but let's test some cases to investigate this. Yeah. Like if you, let's say that A is 2 and B is 3, then on the left you have 1/5, and on the right you have 1/2 plus 1/3. I mean, the right-hand side is definitely bigger. And moreover, do you see any kind of relationship here? Do you see anything happening that is general? If you look at the relationship between the 2's and the 3's, if we have positive numbers in the denominator, what happens when you have a bigger positive denominator versus a smaller positive denominator? In other words, like, just don't even think about 1/2 plus 1/3, but just think about 1/5 versus like either of these individually. Yeah, the 1/5 is going to be less than either of these individual fractions over here, because when you have reciprocals of stuff, when it's 1/over something, 1/over a smaller number is a bigger number, and 1/over bigger number is a smaller number. So, smiley face, if that makes sense. Like, you don't even need to think about adding those two fractions on the right, because in fact, 1/a plus b is going to be smaller than either of those individual fractions. Okay, because a plus b is bigger than a or b. So, 1/a plus b is going to be smaller than 1/a or 1/b. So if you add them together, I mean, remember that 1/a is already bigger than this, and 1/b is already bigger than this. So if you add these together, it's going to be even more bigger than that, so to speak, even more bigger, probably a thing that now is. So that's the only case that you can get. I mean, this is, you are definitely not going to make this happen. If you don't see the pattern, then what you should do is just test cases until it becomes obvious enough to you that this is not going to be a thing. Lexi, that's not what I meant to say. If I said that, that's backwards. If everything has the same sign, then 1/over bigger is smaller, and 1/over smaller is bigger. I mean, if you just think about fractions, that should make sense. Like, you know that 1/1,000,000th is a lot less than 1/2. You know, million's a lot more than 2. I mean, that falls apart if they're allowed to be different signs. Like, if A is positive and B is negative, then A is more than B, and 1/a is also more than 1/b. But everybody here is positive, so this is probably the first thing you ever learned about fractions when you learned what fractions were in grade school or whatever, is that 1/a bigger thing is a smaller thing. So, smiley face, if this makes sense, you can, yeah, I mean, you sure you can. We try it. Try plugging in some fractions on your own, and you'll see. I mean, because they're still positive numbers. So if you try individual fractions for A and B, this will still be the same relationship. But try it. Just on your own time, just throw some fractions in there and see what they do. And I mean, more generally speaking, when there are questions like, what would happen if I blah, 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 just make sure that you investigate that at some point when you review the problem. Just throw other types of things in there and just develop an intuition for it. Let's see what happens if we try to do it with algebra. I don't even know. This would be nice. Let's just find out. Investigate it. So we already discovered that the left-hand side is smaller, but let's try making a common denominator and just see what happens. I mean, that might work too. Let's see. So everybody's common denominator would be AB times A plus B. So that, we got to multiply by that, and then we got to multiply both of these guys by A plus B at the top and bottom. Okay, let's see what we get. Now, and we gotta, sorry, we gotta do more than that. We gotta multiply this one by A and A plus B. And then we got to do the other one by b, a plus b. So let's see what happens if we do that. I don't have room to write that in there, which is why I'm doing that. Actually, I probably do. Just kidding. Let's move that. Okay, we want b, a plus b here. And then we want a plus b there. Okay. If we do that, then the left-hand side is just AB over all that stuff. And then I don't even care. It's just stuff now because it's a common denominator. So I don't even care what it is. And then the rest of this is AB plus B squared. And then we also have A squared plus AB. Oh yeah, this is definitely going to be a nice relationship to see. It's over the same stuff now. Okay. So this is obviously much bigger than that because this is AB plus a whole bunch of other positive things. And this is just AB. So meaning, Smiley, if you see that, I mean, you have the same thing here that you have here. And then you have a bunch of other stuff too. So it should be pretty clear because remember the right-hand side is so much bigger that each of the individual parts were already bigger. So this is definitely smaller, and this is definitely bigger. So there you go. Okay. Any questions about statement 1? Statement 1 is sufficient. Let's talk about statement 2. Also, don't forget, when you figure something out about a statement, and then when you investigate the other statement, you should always think about whether you can take any of the insights from the first statement that you used and use them to make the other statement more efficient. I'm going to go ahead and erase the work for statement 1. Because, okay, like what we've discovered in statement 1 is that if you have 2 positives, then you are always going to check this box. I mean, that was what we just found out with statement 1. So when we investigate statement 2, we know for sure that we need to try negatives because that is going to be the only way we could possibly check this box. I mean, give me a smiley face if that makes sense. Like we discovered from statement 1 that it's going to be less than for all positive net numbers if A and B are both positive. So in other words, we know that we can check this box too. I mean, if you wanted to test a case, we could always test a case. But if I plug in a positive A that's bigger than a positive B, it's going to work out like that. So, for example, if A is 3 and B is 2, then the left-hand side is less than the right-hand side. Because that's just what always happens whenever they're positive. So I multiplied, Suzanne, I multiplied by the same thing on the top and the bottom. That would have been multiplied by A and A plus B, not B and A plus B, because the B is already there. So the missing parts of the common denominator were A and A plus B. Okay. That work is unfortunately gone, so we can't prove it now, but I think it was just standard process of making common denominator. Okay. So we have two positives going to do that. Now, in order to check off this box, we need to try negatives. So no, we definitely don't assume that, because that's the whole point of having separate statements. I mean, statement one means that both are positive, but by no means do we know that. I mean, the whole point of having another statement is that we don't know that anymore. So we need to try at least one of them negative. I mean, let's just try negative. If we want greater than or equal to, we know that we need to try negatives because of the outcome of statement one. So let's try the same thing except negatives. So then we have 1 over -5, which is -1/5. And then Spencer, look for DS, yes. And just search the archive page for yes or no. Just look for the word yes in the archive. That should hook you up. And then on the right-hand side here, we have 1 over -3 plus 1 over -2. You're right. Let's switch those around. Thank you. Iris, I'm just checking to see if you're paying attention. Okay, this is going to be -1/2, -1/3. Well, that is going to be the same kind of thing is happening here, except negatives. So these are both bigger things in terms of magnitude, in terms of how large the numbers are. So this is definitely more negative, and that's less negative. This is a bigger negative number. This is, and this is a smaller negative, which means that the smaller negative is greater in terms of greater than less than side. So, and we can check off that box. So this is not sufficient. Any questions about this? Again, notice that there's lessons here that you should get. I mean, one of them is just setting up the format of the problem in general with this device. It's always a good idea to use that. And as I mentioned to Spencer, we've had workshops where I specifically introduced this device, so check it out. Basically, if you just search for the word yes, no in the archive, you'll find it. And then on top of that, make sure that you streamline the process, try to make it more efficient. Once in statement one, you discover that if you have two positives, it will always be less than. So if you want to get this in statement two, you know right away to try negatives. That sort of efficiency boost. Okay. Any other questions, please type in the chat box. Otherwise, no problem. Let's do one. Let's do another problem. How about this one? Remember where you find the answers to multiple choice questions. Ladies and gentlemen, those are here. Also, this is another yes-no question. So as with other yes-no questions, you should set up this device thing. You should do it all the time. You shouldn't only do it when you think the problem is hard, because then you won't be in the habit of setting it up. So Give it a shot. Okay, if you don't have an answer to this, you should pick one soon. Remember what time management consists of in this exam. It's really just picking things when it's time to pick things. And not picking things. In other words, not sitting there and staring at the screen. Please read the directions. Do not answer in the chat box. You should have multiple choice options. If you are the person who answered in the chat box, please answer in the correct place. Okay, let's talk about it. You got this whole, again, this just get in the habit of setting up something like this. It doesn't have to look exactly like my device, but you should have some sort of thing for yes/no format questions that just keeps the goals in front of your face is pretty much the idea. So, okay, let's take a look at it. Remember, to check the top box off, it has to be the order A, B, C, and then to check off the bottom box, it has to be like anything else. So, I mean, there's no simple way to summarize what a no answer means to this, because there are lots of different orders that could be a no answer, including things being equal and stuff, and different kinds of orders, anything except for that order. So, okay, I mean, statement 2, you can't just say that statement 2 is insufficient because it doesn't mention B. I mean, there were a couple of people asking about this in messaging. You still have to actually prove that statement 2 is not sufficient. I mean, in other words, just because you're missing a variable or don't know anything about one, that's not enough to guarantee not sufficient by itself. Because, I mean, for example, if I gave you something like this, is x less than y squared? If I told you that x is negative, I mean, this would be sufficient. Give me a smiley face if that makes sense. Even though I'm not telling you anything about y, give me a smiley if you see why that would be sufficient. Because, I mean, the point is that y squared is a thing that is 0 or positive already. So if I tell you, even if we don't know anything about y, so if I tell you this, that would mean that it had to be less than. So you can't just notice that B is missing and automatically say not sufficient. So that's not always how it's going to work. I mean, in practice, if you're missing a letter or don't know anything about one, then probably it's going to be not sufficient, just because there's a lot of freedom in those cases, but you still need to actually prove this. So, okay. So VJ, you might use that case to check off one of these boxes. So, but So yeah, statement 2 is basically just A is less than C. I mean, we probably don't need to test actual cases in order to show this, but if you need to, then do it. Because we know that A is less than C, but we do know that B is anything at all. So if we know that A is less than C, but B could be anything. So given that, it's definitely possible that B is between them. So that's possible. And it's also possible for it to not be between them. So we just don't know. We can definitely check off both of the boxes. Give me a smiley face if that makes sense. That's for statement 2. There's also nothing wrong with doing statement 2 first. I mean, if it looks like it's easier to deal with, then that might be the sensible order to do it in. Okay, statement 1. Let's take a look. What does this mean? You need to be careful with the way that you handle this. I mean, it might remind you of what we discovered in the other problem, but there's some chatting going on in the chat box. I mean, the chatting that's in the box is not really accurate because they don't have to tell you something for you to try it. Like what VJ is talking about is that could be a case that you would test if it were necessary to test the case. But okay, so you might look at this and think that it means this. Because remember this observation that we made here about 1 over bigger is smaller. But that observation depends on what? Like, when is that true? Yeah, it's only true if they all have the same sign, right? They don't have to be, it's also true if they're all negative for the same reason. It would just be the opposite order. But yeah, like this might remind you, it should remind you of 1 over less is more. But that's only true if everybody has the same sign. Because if they have opposite signs, it's probably pretty clear that this would be false. I mean, if you had a negative and a positive, then the negative one is going to be smaller both times. So, but if you think about this and realize that that's the exception to it, then this is going to get you more efficiently through this statement. So we know that we need to think about signs here. Okay, like if we have 3 positive numbers, then let's make a table. As with testing cases, just make a table. We need to take 1 over C, 1 over B, and 1 over A, and then those things will tell us what A, B, and C are. And let's start by just taking normal fractions. We do need to obey the instructions, which tell us that these 3 things are in this order. Those are our givens. Okay, let's start with normal fractions like 1/4, 1/3, and 1/2. Easy to start with that. That means that these would just be 2, 3, and 4. So those would check off the top box because they are in that order. 2 is less than 3, which in turn is less than 4. Okay, what are we trying to do now? What are we specifically trying to do? Remember, don't use words like disprove and prove insufficient. Those are not goals. We need to get A, B, and C in an order that is not A less than B less than C. I mean, we need to get them out of this order is the point. So, and one very easy way to do that is just to make one of them negative. So if we just keep the 1/3 and the 1/2, and then we get rid of the 1/4. So let's just replace that with a negative number, like -1. And that means this is also -1. So it's not in the same order. It's in a totally different order. So that's going to check the bottom box. Not sufficient. Any questions about that? You don't get too fancy with the numbers here, right? You just, when you see this, you should be like, well, one very simple way to do that is just to use a negative number. It's kind of reasoning that you want to use. We're not combining them, though. C has to be greater than A. What does that mean? The only answer that I will ever give to what is the difficulty level is no one cares, because you sure don't. Or that will not help you. Thinking about that will not help you solve any of the problems. So don't think about it. It's mental clutter. I mean, think about what it means to have both of these things together. And don't worry about B right now. If we're combining the statements, those things have to be true at the same time about C and A. And we know that 1/C is less than 1/A, and we know that C is greater than A. What does that mean? You may tell me. I mean, these are most definitely not in conflict. I mean, like when you think about this with normal intuition, this should seem normal. I mean, this is like 3 is greater than 2 and 1/3 is less than 1/2. But like, when does this not work? So I mean, ordinarily, if you have a bigger and a smaller, then 1/bigger is less and 1/smaller is more. But if one is negative, yeah, the only time this will not work is if they have opposite signs. I mean, if you need to play around with numbers to show this to yourself, then do it, right? I mean, if they're both positive, this will totally work. And if they're both negative, this will also totally work. And again, just look at, if you need to look at specific cases, then by all means, that's what you should do. But these work together if they're positive. Sure. For example, 3 is greater than 2, and 1/3 is less than 1/2. And I mean, that's probably the normal intuition that you have about 1/anything. That's probably just the first thing you think of. I mean, these also work together if you have 2 negatives. Sure they do. If that's not clear, just throw in some numbers. Like, for example, -2 is greater than -3, and -1/2 is less than -1/3 because it's more negative. So, smiley face if that makes sense. But the only way that this could not possibly work is if they have opposite signs. If A is C is if they have opposite signs. Because, for example, if to make C greater than A, you'd have to make C the positive one. So, like, 3 is greater than -5. But 1/3 is also greater than -1/5. So, it sure does work. That is, oh yeah, no, that's, you have to switch those. Like, this would be the -1/2 is not greater than -1/3. So you can't use that. If you're going to use those numbers, then C would have to be -1/3, and A would have to be -1/2, and they're both true. So that would also work. And yeah, again, it's like what Alex was saying on the other question. If you need to see whether fractional numbers will do this, then just throw fractional numbers in there and see if they do this. I mean, don't wonder whether they will. Just experiment with them and see if it works. So what we know, in other words, what we know from this is that they have the same sign. And then 1/b has to also have the same sign, because everybody has the same sign. All of them do. Smiley face if that makes sense. Could be two positive. It could be all positives. It could be all negatives. But we definitely know that everybody has the same sign. Like we just proved that A and C have to have the same sign. And then because 1/b is stuck between these two things, which have the same sign, it also has to have the same sign. So if everything has the same sign, then that relationship of 1 over less is more is going to work. If all three values have the same sign, you bet it will. Then if I tell you 1 over C is less than 1 over B, which in turn is less than 1 over A, that definitely means that C is greater than B, which is greater than A. In other words, check that box, and this is an impossible box to check. So this is sufficient. And if someone's mentioning 5 and -1, I mean that would not be, that doesn't satisfy statement 1. So you can't use opposite sign values because one of these will be false, depending on how you do it. So those values just wouldn't count. Okay, this is C, cat. So if you put them together, they're sufficient. Any questions about this, go ahead and type them in the chat box. All right, let's see if we got time to do another one. Let's do another one. How about this one? Don't forget where the multiple choice answers are found. Those are here. And also it would help you to make that device. So make that device. Okay, remember that you should remember what time management is and isn't. And time management is just quit when you're stuck. That's all that time management is. So if you're stuck, you should quit. If you don't have an answer selected, you should pick one. Also, don't forget the stuff that's in the question prompt as far as conditions go. Like if you have something after the word if, that's another given fact, and you have to use it. So don't forget that. It's a thing. Let me move this up here. Like if you get a result that's not an integer, then make sure that you discard it because you have a condition that says it has to be an integer. So, okay, P is n% of n. I mean, this is probably not the kind of thing that you can test cases for because it's just not that easy to pick things that do this. I mean, how many numbers can you come up with off the top of your head that are, like, you get a case that someone put in the chat box with 63%. That 63% of 63 is not an integer, so you would have to reject that case. I mean, this is never the conditions. Conditions are a thing. Okay. P 10% of 10 is, yeah, that would. Okay, so let's take a look at it. 10% of 10 is an integer. That would work. And I mean, obviously 100% of 100 is an integer too. But let's just write this as an equation. Because I mean, at least this statement here is not very hard to write as an equation. So that's what we should do. Like, it's, in general, when you get these kinds of things, like sometimes it'll be equally straightforward to approach it algebraically or by testing cases. But sometimes one of those things is just going to be really hard to do. I mean, there's no systematic way to pick cases that do this, is the point. Like, you can, 10% of 10 works because that's 1. And like, I mean, obviously 100% of 100 is an integer. But above that, it's kind of hard to make up cases that'll do this. Like, you can't just randomly come up with those. On the other hand, this is totally straightforward to write as an equation. So we should write it as an equation and just see what happens. So let's do that. P is equal to n%. N% is n over 100. You can also use point or 1n if you like decimals better. But fractions are usually a better way to do it at first. So P equals n over 100 times n. So P is n squared over 100. And remember that this also has to be an integer. And so is n. N is an integer. So also, what is this really asking? Like, what is square root of P a positive integer? What's another way of saying that? Like, if you don't want to think about the square root of P, yeah, because if the square root of something is an integer, then that means it's a perfect square. So you can also rephrase it like this. This is exactly the same thing as, is P a perfect square? Give me a smiley face if that makes sense. You have to be really, you need to exercise extreme caution whenever you transform a question, because normally transforming questions is a minefield of potential mistakes. But if something is very clearly the same as some other form, then feel free. So, and then we can also put that on the on that device where we translate the yeses and the nos. We should also do that. So P is a square, and P is not a square. Those are the two things that are the goals. I mean, if you do come up with alternative phrasings of stuff, you should absolutely put them on that device, just so that you can use either of them. Give me a smiley if that makes sense. Okay, so P is n% of n. Well, this is a square of something, because this is n over 100 times, sorry, this is n over 10 times n over 10. But the question is that actually a perfect square of an integer or not? So, see, because we're definitely squaring something here. Sure we are. But the problem is, do we know? Are these integers? Do we know that? We got to think about that. Yeah, we got a condition that says n squared over 100 is an integer. This is the given condition. So we know that n squared divided by 100 is an integer. It has a whole number from the condition. So that means that 100 goes into n squared. So n squared is divisible by 100. N squared is. In other words, 10 times 10 is part of n squared, which means that n is divisible by 10. So actually, these are integers. Like n over 10 actually has to be an integer, otherwise p would not work out to be 1. Like if you try something like, if you try n is 1, you'll see why this doesn't work, right? If you take 1% of 1, that ends up being that decimal. So 100p is n squared is the same as what we have here. You can, if rephrasing it like that helps you, then by all means. So yeah, n is divisible by 10. Well, thanks for the kind words, because I wrote this question. So thanks. The square of an integer. So this is a perfect square. How about that sufficient? It's pretty neat, yes. So statement 1 is sufficient. Now let's take a look at statement 2. I'm glad you guys liked the question. Statement 2 just tells you that p is some multiple of 100. So that's not going to tell us. I mean, it could be a perfect square. Sure, it could. So that's basically all this means. P is a multiple of 100. Some multiple of 100. I mean, if P is 100, it's a perfect square. But if P is like 200, then it's not. Yeah, or 300, which was mentioned in the. That's enough to check the boxes. So if it's 100, it checks the top box. If it's 200, it checks the bottom box. So this is not sufficient. And we don't need to combine them because statement 1 was sufficient. So that means that this is A, alligator. Good times. All right, that is, having like 3 minutes till time is technically up. It's definitely not enough time to do another problem. So we are going to call it a day. Thanks for all the compliments on this question. We definitely don't have time to do another one. I mean, we only have like 3 minutes. So we're just going to wrap up 3 minutes early. Most of these sessions have gone over a bit, so definitely it's just making up for that a little bit. But, okay, cool. I think we're going to do verbal next time of some kind. I don't know exactly what until, I usually don't have any idea until pretty much the day of. So stay tuned. Let's kill the recording. Good afternoon, good evening, good night, good morning.